So now next 0.6 volt sample is next quantized, encoded, and then transmitted. This is the scenario in PCM communication system. That means in PCM communication system, each and every sample value is converted into some group of binary bits. Each and every sample value is converted into some group of binary bits. So we are going to transmit all the binary bits used to encode a sample. We are going to transmit all the binary bits corresponding to each and every sample. For example, let us consider 1.8 volts. Eight number of binary bits are there corresponding to 1.8 volts. And also consider the 2.6 volts. 8 number of binary bits are there. We are going to transmit all the 8 number of binary bits. Right. Next 0.6 volts sample is encoded into 8 number of binary bits. That means each and every sample is encoded into some number of binary bits. We are going to transmit all the number of binary bits corresponding to each and every sample. That means for each sample we are going to transmit multiple number of bits. This is the scenario in PCM communication system. Is it okay? Next, let us consider the Dpcm system. So in this particular Dpcm system, same example I consider for the this is the example I consider for the PCM system. I'm going to consider the same example for the Dpcm system. Okay, so in the Dpcm system, in the DPCM system, for example, if you want to transmit the sample at one point at time t is equal to 1 in DPCM system, if you want to transmit the sample that is available at time t is equal to 1, is it okay? So let us consider that particular sample. Okay, so this I consider this particular sample as a present sample. I consider the last sample as a previous sample. Okay, so at time t is equal to 1, what we are going to transmit? At time t equal to 2, what we are going to transmit? Is it okay? So at time t equal to 1, we are going to transmit the amplitude difference between the previous sample and present sample. If you consider 2.6 volt sample as a present sample, what is a previous sample? Right? If you consider 2.6 volts as a present sample, what is the previous sample? Students, tell me. Hello.
1.8.
1.8 volts, right? So what is the amplitude difference between the 2.6 and 1.8 volts? What is the amplitude difference between the 2.6 and 1.8 volts?
0.8.
All right. So what is the information that is transmitted at time t equal to 1? So the amplitude difference between the two adjacent samples, which is nothing but 2.6 and 1.8. So that is so present sample value is equal to 2.6 and previous sample value is equal to 1.8, isn't it? Right. So the error between the present sample value and previous sample value is, sir, the error between the present sample value and previous sample value, which is nothing but error is equal to present sample minus previous sample, that is nothing but 0.8 volts. So now this particular 0.8 volts is quantized, and after the quantization of this error, now this 0.6 volts is quantized to what? Let us consider this particular 0.8 volts error signal is quantized to 1 volt. Let us say it is an example only. Now this particular 1 volt level is quantized. Okay, so we are not going to transmit the actual sample value here in DPCM. Okay, in DPCM the amplitude difference between the two samples is quantized, encoded, and are transmitted. Let us consider this one, 2.6 minus 1.8, that which is nothing but zero point 0.8. 0.8 is quantized, 0.8 is encoded, 0.8 is transmitted. Is it okay? Let us consider at time t equal to 2. So if you consider time t equal to 2, what is the present sample value at time t equal to 2? Say your answer, students. Hello. If you consider
0.6, sir.
Now let us consider the time instant, time t equal to 2. Okay, if you consider the time t is equal to 2, what is the present sample value and what is the previous sample value? Students, what is the present sample value and what is the previous sample value?
Present sample value
0.6
point.
value.
Oh, present sample value is 0.6 and previous sample value is 2.6. Okay, let us calculate the error. Present sample value minus previous sample value, which is nothing but 0.0 minus 0.6. And this minus 0.6 is quantized and then encoded and then corresponding bits are transmitted. So each time, at each and every time instant, at each and every particular in DPCM, at each and every time instant. Okay, so we are going to calculate the present sample value minus previous sample value. We got some particular amplitude difference. That particular amplitude difference is quantized. That particular amplitude difference is encoded. That particular amplitude difference is converted into group of bits. Those bits are we are going to transmit in DPCM. So this is the scenario in DPCM system. Okay, so let us consider the next modulation system. So that means in DPCM and PCM, in DPCM and PCM. So for example, if you consider the if you consider the PCM system, so is each sample is converted into some multiple bits, multiple bits, multiple binary bits. Each and every analog sample value is converted into multiple number of binary bits. Okay, so that means we are going to transmit multiple number of bits per sample. We are going to transmit multiple number of bits per sample. Okay, so for this, that means if you consider the DPCM system, so that means number of number of bits number of bits transmitted per second is equal to more value in DPCM. Okay, and here the number of bits transmitted per second is equal to less value in DPCM. So in DPCM system, we are transmitting the error value. In PCM system, we are going to transmit the actual sample value. In DPCM system, we are going to transmit the amplitude difference between the two adjacent samples. Since the error value is low, so less number of bits are enough to represent the error value. So therefore, we are going to transmit only few number of bits per second. So therefore, bit rate is very low. Since the bit rate is low, bandwidth is also low. Here the bandwidth is high. Bandwidth is high. Okay, if you want to further reduce the if you need to reduce the bandwidth further, అంటే ఇంకా bandwidth తగ్గించాలి అంటే PCM నుంచి DPCM రావడం వల్ల bandwidth తగ్గింది. Bandwidth తగ్గడం వల్ల మనకి advantage. Bandwidth must be as low as possible. Okay, always we are aiming at low amount of bandwidth. Always we are aiming at low amount of bandwidth. So as we move from PCM to DPCM, obviously there will be a decrease in the bandwidth. Okay, if you need to still reduce the bandwidth, then we go to the delta modulation. That is called delta modulation. Delta modulation. If you want to further reduce the bandwidth, then we go for the delta modulation. So what is the scenario that is used in the delta modulation? Right. So scenario, this is you know that PCM system is nothing but what is a PCM system? PCM transmitter. What is the action of the PCM transmitter? Anybody? Hello. What is the action of the PCM transmitter? Hello.
Converts analog signal into digital.
Right. So every time only one person is responding. All of you remaining persons also, please respond to me. Right. So in the PCM communication system or PCM modulation system is a system which converts analog signal into digital signal at the transmitter side. Again, at the receiver side, digital information is converted into the analog information. Okay, and your delta modulation is also same. Delta modulation technique is a technique which is used to convert analog signal into digital signal. Okay, and it is a delta modulation is also a technique which converts analog signal into digital signal. Is it okay? So for example, if you apply a analog signal to the delta modulator, if you apply a delta analog signal to a delta modulator, then what is the output of the delta modulator? Digital signal. Okay, so digital signal. And also in this particular delta modulation, simply delta modulation technique is a technique which converts analog signal into digital signal. Is it okay? Right. In delta modulation, step size, that means a quantizer step size is fixed. Quantizer step size is fixed. This is a very, very important point. Okay, so you need to remember this particular point. This is a very important point. In delta modulation, the step size of the quantizer is fixed. Step size of the quantizer is fixed. Okay, so and the next point regarding to the delta modulation is delta modulation transmits only 1 bit per sample. Only 1 bit per sample. So okay, so what is the meaning of 1 bit per sample? Anybody? What is the meaning of 1 bit per sample? Anybody? In PCM, per one sample, how many number of bits are transmitted?
Multiple bits.
Right, very good, Amma. So in PCM, per one sample, per one sample, we are going to transmit multiple number of bits. In DPCM, sorry, in DPCM, in DPCM, we are for one sample, we are going to transmit multiple bits. In delta modulation, per one sample, we are going to transmit only one binary bit. Only one binary, only one binary bit is transmitted per one sample. For example, let us consider one example only. 8 bits are transmitted. Assume that 8 number of bits are transmitted per one sample in PCM. For example, let it consider 4 number of bits are transmitted per one sample. For example, based on the error, so the bit sizes bits are bit length, binary bit length varies in DPCM. For example, 4 bits. In delta modulation, we are going to transmit only one binary bit per each and every sample. Okay, we are going to transmit only one binary bit per each sample. We are going to transmit only one binary bit per each sample. Is it okay? Right, this is a scenario in DRAM. So in delta modulation transmits only one bit per sample. Is it okay? Right. So since the delta modulation transmits only one bit per sample, the bit rate in the delta modulation is very, very less. Isn't it? Antena? So you know that bit rate. What is the meaning of the bit rate? Bit rate is nothing but number of bits transmitted per second. Bit rate is nothing but number of bits transmitted per once number of bits transmitted per second. So number of bits transmitted per second. Okay, in case of delta modulation, the bit rate is very less. Why bit rate is very less? Anybody? Anybody? Why bit rate is very less? Anybody? Why bit rate is very less? Anybody?
Only one
Hello?
bit transmitted, sir.
Ah, so we are going to transmit a single bit per each and every sample. Okay, because of this particular thing, since the delta modulation transmits only one bit per sample, the data rate that or bit rate in delta modulation is very less. If the bit rate is very low or very less, then the bandwidth of the delta modulation communication system is also less. Okay, always there is a directly proportionality between bit rate and bandwidth. If the bit rate is less, bandwidth is less. If the bit rate is high, bandwidth is high. In delta modulation, bit rate is very less. Because of this, bandwidth is also very less in delta modulation. So this is the main advantage of the delta modulation or the PCM communication and or the PCM and DPCM. Okay, bit rate and bandwidth are very less in delta modulation. Bit rate and bandwidth are very less. So now all of you please listen here. So this is the scenario in delta modulation. Bit length and bit rate and bandwidth is very less in delta modulation. Is it okay? So now let us consider this. Let us consider this is the analog signal. Analog signal is given as input to the delta modulator, and how analog signal is converted into digital signal by using delta modulator. Let us see. Right. So all of you please consider so all of you please listen here. So it is the n-log signal x of t. It is the n-log signal x of t. Okay, and this particular we are going to convert this particular signal analog signal which is in yellow color. We are going to convert this particular analog signal into digital signal. Let us see how this particular analog signal is converted into digital signal. Is it okay? Right. So now all of you see here. So this particular analog signal is approximated by the staircase waveform. All of you see here. So here the signal, here one signal is represented. So this signal is this signal which is in yellow color is an analog signal, which we need to convert this particular signal into digital signal. Okay, let us consider this signal and approximate this particular signal by a staircase waveform. Okay, what is the approximation procedure? ఇందాక మీకు చెప్పానండి, ప్రెజెంట్ శాంపుల్ని ఎర్రర్ ఎలా క్యాలిక్యులేట్ చేస్తామమ్మా? ఎర్రర్ చెప్పాను ఇందాక చెప్పేటప్పుడు మీకు చెప్పాను. సో డిపిసిఎం సిస్టమ్ ముందు చెప్పాను. ప్రెజెంట్ శాంపుల్ ప్రీవియస్ శాంపుల్ తీసుకుంటాము. ప్రెజెంట్ శాంపుల్కి ప్రీవియస్ శాంపుల్కి మధ్యలో ఉండే దాన్ని ఏమంటారు? What is the amplitude difference between the present sample and previous sample? So which is nothing but error. Is it okay? So we are going to consider the same error here. Now for the first block in the delta modulation is comparator. Okay, so what is this comparator? So this comparator inputs are input signal. Input signal means analog signal which we need to convert into digital. ఓకే, సో ఏదైతే మీరు ఎనలాగ్ సిగ్నల్ని డిజిటల్ ఫార్మాట్లోకి చేంజ్ చేయాలనుకుంటున్నారో ఆ పర్టికులర్ ఎనలాగ్ సిగ్నల్ని డెల్టా మాడ్యులేటర్కి ఇన్పుట్గా ఇస్తారు. ఓకేనా? డెల్టా మాడ్యులేటర్గా ఇన్పుట్లోకి ఇచ్చిన తర్వాత మీరు ఇచ్చిన ఎనలాగ్ సిగ్నల్ ఫస్ట్ దేనికి రీచ్ అవుతుందంటే డెల్టా మాడ్యులేటర్లో ఉన్న కంపారేటర్ బ్లాక్ రీచ్ అవుతుంది. ఓకేనా? మీరు డెల్టా మాడ్యులేటర్కి ఎనలాగ్ సిగ్నల్ అప్లై చేస్తారు. మీరు అప్లై చేసిన ఎనలాగ్ ఇన్పుట్ సిగ్నల్ అనేది డెల్టా మాడ్యులేటర్లో ప్రెజెంట్ అయ్యున్న కంపరేటర్ అనే బ్లాక్ వెళ్తుంది. ఓకే, అండ్ వాట్ ఈస్ అనదర్ ఇన్పుట్? సో నౌ ఇట్ ఈస్ ద ఆల్ ఆఫ్ యూ లిజన్ హియర్. దిస్ ఈస్ ద డెల్టా మాడ్యులేటర్ బ్లాక్ డయాగ్రామ్. సో దిస్ ఈస్ ద డెల్టా మాడ్యులేటర్ బ్లాక్ డయాగ్రామ్. ఓకే, సో ఇట్ ఈస్ ద present sample value, and this is a 1-bit quantizer, and now this is called the delay unit. These are the various blocks available in the delta modulator. Okay, and the previous sample is approximated. That means here all of you listen here. So here one input to the comparator is input signal. Okay, and input signal, that is analog signal. This is nothing but present sample value. Okay, and another input to the comparator is a last approximated value or last sampled value or last quantized value, which is nothing but last sample or previous sample value. Okay, so here, so it is called present sample value and it is called last approximated value or last quantized value or last sample value. So these are the various things. Okay, so what are the two inputs to the comparator, students? What are the two inputs to the comparator, students? In delta modulation, what are the two inputs to the comparator, students? Please tell me.
Input signal and approximated signal.
Approximated signal means last quantized signal. That means last sample is quantized. ఓకే, లాస్ట్ శాంపుల్ ఫర్ ఎగ్జాంపుల్ ఒక శాంపుల్ ఇచ్చామమ్మా. శాంపుల్ ఇచ్చిన తర్వాత ఏమవుతుంది? ఆ శాంపుల్ని క్వాంటైజ్ చేస్తుంది. ఆ శాంపుల్ క్వాంటైజ్ అయిపోయిన తర్వాత ఏమైపోతుందంటే అది లాస్ట్ శాంపుల్ అయిపోతుంది. ఓకే, లాస్ట్ క్వాంటైజ్డ్ శాంపుల్ విచ్ ఈస్ నథింగ్ బట్ ప్రీవియస్ శాంపుల్. ఇస్ ఇట్ ఓకే? లాస్ట్ అప్రాక్సిమేటెడ్ శాంపుల్ or approximated sample or last quantized sample, which is nothing but previous sample. So here it is the present sample value and it is nothing but previous sample value. Present sample and previous sample are applied as input to the comparator. Okay, so the which is nothing but approximated signal, which is nothing but approximated signal. Okay, here this particular, these are the two inputs to the comparator are, so present input sample and last input sample or last approximated signal. Okay, and present input is represented by x of nts. Students, is it okay? Am I understandable? నేను చెప్పేది అర్థం అవుతుందండి?
Yes,
Hello,
sir.
right. So present sample, all of you, what is the representation for present sample? What is the representation for present sample? Hello, what is the representation
X
for
of NTS.
x of nts? And what is the approximated signal? That is the last sample.
X
Last
cap
sample,
of NTS.
last sample is represented by, or previous sample is represented by x cap of nts, and present sample is represented by x of nts. Okay, here always the comparison is in between the two signals: present sample, previous sample, present sample, previous sample, present sample, previous sample. Previous sample is nothing but approximated signal, quantized signal, previously quantized signal, or previous sample. Previous sample is quantized. After the quantization, that signal is nothing but last approximated signal. Last approximated signal is nothing but previous sample. Is it okay? Previous sample or last approximated sample is represented by x cap of NTS, and present sample value is represented by x of NTS. Okay, these are the two inputs applied to the right here. So it is very, very important scenario. All of you please remember this one. Okay, so here the present sample value is greater than last approximated signal, that is previous sample. Present sample value is greater than previous sample value or last approximated signal. What are the things? Okay, so if the present sample value is greater than last approximated signal, then what is the difference? Difference means present sample value. Difference is nothing but comparator. Comparator is a circuit which performs the subtraction operation. Is it okay? So it calculates the difference between the present sample value and last approximated value. Okay, so comparator, these are the two inputs applied to the comparator. What is the function of the comparator? Comparator performs a subtraction operation between the input sample value, that is the present sample value, and last approximated sample value. It calculates the difference. Okay, difference is provided at the output of the comparator. Is it okay? So this particular difference may be positive and negative. అంతేనా అమ్మా? కంపరేటర్ ఏం ఆపరేషన్ చేస్తుంది అంటున్నాను నేను ఇక్కడ? What is the operation that is done by the comparator? Subtraction operation. Okay, subtraction operation between present sample value and last approximated value. Okay, it performs a subtraction between two inputs and gives the difference as the output. Okay, if this particular difference may be positive or negative, isn't it? So for example, if the input present sample value is greater than last approximated signal, then the difference is positive. Is it okay? For example, let us consider the another case. If the present input sample value is less than, if the present input sample value is less than last approximated value, in this case, what may be the difference? In this case, what may be the difference? Negative. Okay, present input is greater than last approximation. The difference that is generated by the comparator is positive. Okay, next, if the present input sample value is less than last approximated signal, then the difference that is generated by the comparator is negative. Okay, what happened if the difference is negative? What happened if the difference is positive? Let us see. When the difference is positive, approximated signal is increased by delta. Approximated signal is increased by delta when the output of the comparator is positive. When the difference is positive, the approximated signal is increased by delta size, 1 delta size. Here, please keep it in mind, in delta modulation, always the delta is fixed. We may either increase the delta value or decrease the delta value. In which case we increase the delta value, in which case we decrease the delta value. That is a very important thing. If the output of the comparator is positive, that means when the difference is positive, then approximated signal is increased by 1 delta. 1 delta, right? So if the output of the comparator is negative, if the output of the comparator is negative, that means when the difference is negative, then approximated signal is decreased by 1 delta. If the output of the comparator is positive, then approximated signal is increased by 1 delta. If the output of the comparator is negative, then approximated signal is decreased by 1 delta. Decreased by 1 delta. Is it okay? Right. So if the staircase waveform, that means if the quantizer increases by 1 delta, then logic 1 is transmitted. Logic 1 is transmitted. Is it okay? Next, if the approximated signal is decreased by 1 delta, in this particular case, logic 0 is transmitted. This is a scenario in delta mod. This is a basic operating principle of the delta modulator. Delta modulator. Is it okay, students? Delta modulator basic operating principle is this one, right? What is the operation? Anybody please tell me. Present value, present input sample value is always compared with the last approximated signal. If the present input sample value is greater than last approximated sample value, then the output of the comparator is positive. Okay, if the output of the comparator is positive, then approximated signal is increased by delta, not decreased. Please keep it in mind. Increased by delta. Approximated signal is increased by, that means quantizer increased by, quantizer increased its step size by delta. Okay, right. That means and whenever the step size is increased by delta, then logic 1 is transmitted in delta modulation. So let us see the another case. Let us see the another case. If the input sample value, if the input present sample value, if the input present sample value is less than last approximated signal, in this case, what happened? The output of the comparator is negative. Okay, if the output of the comparator is negative, then approximated signal is decreased by 1 delta. Decreased by 1 delta. Is it okay? Students, is it okay? Right. If it is decreased by 1 delta, then logic 0 is transmitted. Is it okay? So present sample value and its corresponding logic 1 or 0. That means each and every sample value is compared with the previous sample value or last approximated signal value. Each and every input sample value is compared with the previous sample value, which is nothing but last approximated value. Based on the based on the uh, based on the difference between the input sample value and last quantized value, we need to send either 0 or 1. Either 1 or logic 1 or 0 is transmitted by the delta modulator. Okay, that means in this way the delta modulator transmit either 0 or 1 per each sample. Is it okay? This is a scenario in delta modulation. Right. Let us see graphically. All of you please listen here. Is the screen is visible to you, students? Hello?
Yes, sir.
Hello? Right, right. Okay, every one of you see what is a signal that is available in the yellow color? What is the signal that is available in the yellow color?
Present sample value.
Present sample value or analog signal value. Isn't okay? Right. Yellow signal, the signal which is represented in the yellow color is the signal of analog signal. Is the analog signal. Okay. We need to convert this particular analog signal into digital signal. Okay. Here, I will show the. I am showing the one more signal. Which is indicated by green color. green color is called a last approximated signal. Green color signal is called last approximated signal. Yellow color signal is called present signal or present sample value, which is nothing but analog signal. Okay, last always, all of you please students carefully listen here. Always here the present sample value, which is in yellow color, is compared with the last approximation value, which is in green color. Okay, so now here all of you see here last last approximation is represented by green color. Present sample value is represented by yellow color. Okay, so now all of you see here present sample value is this one and last sample value is this one. Now in this case the present sample value is compared with last approximation. Which one is greater here, students? Here I am showing the present sample value and last approximation value. Which one is greater? Present sample value is greater or last approximation value is greater? Tell me. ఏది ఎక్కువగా ఉంది? Hello? Hello? Students. Which one is greater? Present sample value is greater or last approximation value is greater?
Present sample value.
Present sample value is, if the present sample value is greater than last approximation value, what happened? Chip and Mikindada. If the present sample value is greater than last approximation value, what happened?
Positive.
What happened? Present sample value is greater than last approximation sample. Then what happened?
Difference will be positive.
Difference is positive. If difference is positive, what happened? Difference is positive, what happened?
Logic
Logic
one
increased by 1 delta.
Approximated signal is increased by 1 delta. Okay, you need to increase the step size by 1 delta. Okay, since the present sample value is greater than last approximation, you need to increase the last approximation by 1 delta. Increase the last approximation by 1 delta. Okay, increase the next one is next, see the next one. ఓకే, నేను ఏం చేశాను లాస్ట్ దానికి ఇప్పటికి డిఫరెన్స్ చూడండి. స్టెప్ సైజ్ ఏమైంది? పైకి ఇంక్రీజ్ అయింది చూడండి. స్టెప్ సైజ్ నెక్స్ట్ చూపించే దాంట్లో స్టెప్ సైజ్ ఇంక్రీజ్ చేయాలి. చూడండి ఇక్కడ నుంచి చూడండి. లాస్ట్ అప్రాక్సిమేషన్ ఇస్ దిస్ వన్. ఇంక్రీజ్ చేశాను, ఇంక్రీజ్డ్ బై 1 డెల్టా. ఇంక్రీజ్ చేస్తే ఏం చేయాలి మనం? 1 చేయాలా, 1 ట్రాన్స్మిట్ చేయాలా, 0 ట్రాన్స్మిట్ చేయాలా? హలో, 1 ట్రాన్స్మిట్ చేయాలి. ఓకే, సో ఇట్ ఈస్ ద లాస్ట్ శాంపుల్. It is the next, here it is a last increased by 1 delta. This is increased by 1 delta. If it is increased by 1 delta, then you need to transmit logic 1. Is it okay? Right. Next one. Now this is the present sample value. Here, here this is the last approximation. Now, so this is the last approximation. Now in this case, this is the last approximation. This particular last approximation is compared with the present sample. Okay, this is the last approximation. This is compared with the present sample value. Again, which is greater? Last sample greater or present sample value greater? Which one is high? Present sample value ఎక్కువ ఉందా? Last approximation value ఎక్కువ ఉందా?
Present sample.
Present sample value ఎక్కువ ఉంది. So what we need to do? If the present sample value is greater than last approximation, what we need to do? You need to increase the step size by
1 delta.
1 delta. నేను నెక్స్ట్ చూపించే ఫిగర్ లో 1 డెల్టా ఇంక్రీజ్ అవుతుంది చూడండి. మళ్ళీ 1 డెల్టా ఇంక్రీజ్ అయింది. సో హియర్ 1 డెల్టా. ఆల్ ఆఫ్ యూ కన్సిడర్ ద లాస్ట్ వన్. Present sample is greater than last approximation. Therefore, you need to increase the step size by 1 delta. Increase the step size by 1 delta. So when there is an increase in the step size by 1 delta, logic 1 is transmitted. Is it okay? Logic 1 is transmitted. Right. Next becomes this is the present sample value and last approximation. Which one is greater again? Tell me.
Present sample.
Present sample, if the present sample is greater than, what we need to do?
The approximate signal increased by 1 delta.
Approximated signal increased by 1 delta, right? Again, I increase the approximated signal by 1 delta, so which is nothing but here. Okay, again I transmit the 1, since there is an increase in the step size by 1 delta, since there is an increase in the step size by 1 delta, so therefore logic 1 is again transmitted. Is it okay? Next one is so this is the scenario. Okay, last step proxy. Again, see here, ala step size increase chesto. So these are the various bits transmitted. Okay, so next, this is the last approximation, and this is the next sample, present sample. Which one is greater here? Look at this figure.
Last approximation.
Okay, in all the previous cases, present sample is greater than last approximation. Now, in this case, present sample value is greater or last approximation value is greater?
Last approximation sample.
Last approximation value is greater. Okay, so if the present sample value is less than, last approximation value, then what we need to do? What we need to do?
Should be decreased by the approximation signal is decreased by 1 delta.
Very good, Amma. Last approximated signal will be decreased by 1 delta. నేను నెక్స్ట్ చూపించే ఫిగర్ లో ఏమవుతుంది? స్టెప్ సైజ్ డిక్రీజ్డ్ బై 1 డెల్టా. చూడండి ఇక్కడ స్టెప్ సైజ్ డిక్రీజ్ చేశాను. When there is a decrease in the step size by delta, what you need to transmit? Logic 0 or logic 1?
Logic 0.
Logic 0. Is it okay? Right. So in this way, the entire here all of you show this is the last approximation and the present sample value. Which one is greater? Last approximation is greater. If the last approximation is greater, you need to decrease the step size by delta. So therefore,
1 delta.
In the next one, I decrease the step size by delta. Delta decrease చేశాను కాబట్టి 0 transmit చేశాను. Okay, so now this is the scenario in delta modulation. Okay, if the present sample value is greater than last approximation, increase the step size by delta, 1 is transmitted. If the present sample value is less than last approximation, then you need to decrease the step size by delta. Okay, and logic 0 is transmitted. So this is the basic operating, this is the analog signal. All of you see here. So the signal which is represented in the yellow color, that is which is nothing but analog signal. Okay, and the signal that is represented in the green color is called approximated signal. Your analog signal is approximated by the staircase waveform. మెట్లు లాగా ఉంది కదమ్మా ఇది వేవ్ ఫామ్, దాన్ని స్టేర్ కేస్ వేవ్ ఫామ్ అంటాం. Analog signal which is in yellow color is approximated by the staircase waveform. Analog signal is approximated by the staircase waveform which is in green color. Okay, here, so at the bottom, below the time axis, here bits are represented 0 1 1 1 1 1 1 1 1 0 1 0 0 bits are represented. These are the digital equivalent. These are the digital equivalent bits corresponding to analog signal which is in yellow color. Finally, analog signal which is in yellow color is converted into digital bits which are represented below the time axis 0 1 1 1 1 1 1 0 1 0 0. So in this way, your delta modulator converts analog information into digital information. Okay, so the prime advantage of the delta modulation over PCM and DPCM is, anybody? In delta modulation, how many bits are transmitted per one sample?
Only 1 bit.
Only one bit is transmitted per each and every sample. Because of this particular advantage, bit rate of the delta modulation is very less. If the bit rate is very less, the bandwidth of the delta modulation is also very less. That means the bit rate and bandwidth of the delta modulation is very less when we compare with the bit rate and bandwidth of the PCM system and Dpcm system. That's why we move from PCM to delta modulation. That's why we move from Dpcm to delta modulation. Is it okay, students? Students, is it okay?
Yes,
Hello.
sir.
Right. Okay,
Yes,
thank
sir.
you. చెప్పండమ్మా, డౌట్ ఏమైనా ఉందా?
సార్ మరి ట్రాన్స్మిట్ చేసిన తర్వాత ఒకే లైన్ లో వస్తుంది కదా సార్ సిగ్నల్ 0101 అనేది.
ఒకే
మనం
లైన్ లో అంటే
పంపించేదేమో స్టేర్ కేస్ కదా సార్.
మనం పంపించే స్టేర్ కేస్ కదమ్మా, అప్రాక్సిమేట్ చేస్తున్నాం. సో వీ హ్యావ్ ఎనలాగ్ సిగ్నల్. We apply the analog signal as an input to the delta modulator. That particular analog signal is approximated by the another signal that is called staircase waveform. Based on the staircase waveform increases and decreases, we are going to transmit either logic 0 or logic 1. అర్థమవుతుందమ్మా?
ఓకే సార్, అర్థమైంది సార్, అర్థం.
ఓకే అమ్మా, థ్యాంక్ యూ. You may leave the class. Thank you one and all. If anybody have doubt, please ask me, or otherwise please leave the session.